Welcome to The Explainer. Today, we're diving into the story of a scientist whose work was absolutely essential to one of the biggest discoveries of the 20th century. But here's the thing. Why have so few of us ever heard the name Rosalind Franklin?
Okay, so let's start with a question that honestly connects every single one of us to this story. I mean, have you ever wondered why you look the way you do? Where do your traits, your features, actually come from?
Well, the answer, as you probably know, lies in our genes. You can think of them as these biological blueprints that get passed down through generations, and they dictate pretty much everything, from your eye color to, the way you smile. And what are these genes made of? This truly remarkable substance called DNA. Now, back in the mid-20th century, scientists knew DNA was a big deal, but they were in this frantic race to figure out one crucial thing. What did it actually look like? Its shape. That was the key to understanding how it all worked. And this is where Rosalind Franklin comes in. Born in London in 1920, she was a scientist who was, uniquely equipped with the skills and the intellect to help answer that very question.
And her brilliance? Oh, it was obvious from a super young age. Her own aunt described her as alarmingly clever, and get this, she did arithmetic for fun. That just hits at a mind that was wired completely differently from the get-go.
And it wasn't just her mind. Her upbringing was just as formative. She grew up in a family that really valued social responsibility and academics. I mean, they were politically active, involved in charity, and even took in refugee children fleeing Europe during World War II. So this whole environment, it really gave her a powerful sense of purpose.
And this really shows you that her character was so much more than just a sharp mind. She had a deeply compassionate heart. When she won a prestigious scholarship to college, what did she do? She gave the money to a refugee student who she felt needed it more. Just amazing.
So her path from there was, it was seriously impressive. She studied chemistry at Cambridge, then put her skills to work during the war, actually improving gas masks. But the real game changer was her time in post-war France. That's where she mastered X-ray crystallography, this incredibly difficult technique for taking pictures of microscopic structures. And that one skill, it was about to change the course of science forever.
So in 1950, that expertise in X-ray crystallography brings her back to London, to King's College, with a very specific mission: figure out the structure of DNA. Now, the start there was a little rocky. There was some misunderstanding with a colleague, but Franklin was focused. She just launched straight into her work.
And to really get why this was such a big deal, the Lego analogy is perfect. Think of your body as a massive Lego set, right? Your cells have all the bricks, all the machinery, but the DNA, that's the instruction booklet. Without it, the machinery has no idea how to build you. Not your eyes, not your muscles, not anything.
And believe me, scientists were buzzing with excitement. See, just a few years earlier, it had been proven that DNA was the stuff that carried genetic traits from parent to child. So all of a sudden, figuring out its physical shape, that became one of the biggest prizes in all of science. Everyone wanted to be the first.
So, working meticulously with her assistant, Raymond Gosling, Franklin got to work. She refined the equipment, she perfected the techniques she learned, and after hours and hours of careful, painstaking work, she captured this image. It's now known as Photo 51, and it was, without a doubt, the single clearest, most detailed picture of DNA that had ever been taken.
Now this photo, this was the key. To you and me, it might just look like a blurry X, but to Franklin, with her expertise, it revealed a crystal clear pattern. By combining this image with her deep knowledge of chemistry, she figured it out. She deduced that DNA was shaped like a twisted ladder, what we now famously call a double helix. So, she had the evidence. She had figured out the structure. But in the super competitive world of mid-century science, that was only half the battle. Getting credit was a whole other story.
And what happened next is what changed history. Franklin's colleague, a guy named Maurice Wilkins, showed Photo 51 to a rival scientist, James Watson. And here's the kicker, he did it without her knowledge, without her permission. For Watson and his partner, Francis Crick, seeing that photo was like a lightning bolt. It was the final, crucial piece of the puzzle they'd been desperately searching for.
And the timeline here, it really tells you everything you need to know. Armed with Franklin's data, Watson and Crick just rushed to publish their model. They got their paper out in April 1953, beating Franklin's own publication by just a matter of weeks.
So what about Franklin? Well, she moved on to a new lab, and she was actually happy to be in a more respectful environment. The incredible thing is, she was completely unaware of the pivotal role her photograph had played in Watson and Crick's big discovery. She just continued to do incredible, groundbreaking science.
Yeah, she went on to make these huge discoveries about viruses, feeling appreciated and valued by her new colleagues. She never knew. She never knew her data had been the absolute key to the DNA model. And then, so tragically, her life was cut short by cancer in 1958, long before the full story ever came to light.
So in 1962, the Nobel Prize for the discovery of DNA structure was awarded to Watson, Crick, and Maurice Wilkins. And Rosalind Franklin, the woman whose photograph was the essential piece of evidence, she received no credit at all during her lifetime.
And the truth, kind of ironically, was finally revealed by James Watson himself. It took a decade, but in 1968, he published a book where he basically admitted he'd seen Photo 51 and acknowledged just how critical it was to their breakthrough.
But, in the end, for Franklin, it was never really about winning a race. This quote, it really gets to the heart of who she was. She saw science as a tool, not just to understand the world, but more importantly, to improve it for everyone. She was just as proud of her work on coal and viruses as she was of her work on DNA, because it all contributed to human knowledge.
And that really leaves us with this final, kind of lingering thought, Rosalind Franklin's story. It was eventually told. She got the recognition she deserved, even if it was far, far too late. But it really makes you wonder, doesn't it? How many other crucial contributions by how many other incredible scientists are still hidden away in the footnotes of history, just waiting to be discovered?